Right, now, just key terminology that we need to know. The size of a test is the probability of a type 1 error. And again, quite often, it's ish the significance level. Now, the power is 1 minus the probability of type 2 error, i.e. the probability of not making a type 2 error. Basically, it gives you how sensitive it is, all right? And you want to have an idea of how sensitive your test is, right? So if I say lambda is 2.8, and in fact, if lambda was 1, there's still a really high chance of me making a type 2 error, then it's not a very sensitive test. This test, is it very sensitive? Well, bearing in mind that we thought it was, so in our test, we're saying 3.2, right, per week. If the actual number of sightings is 5 per week, we still have a 56% chance of accepting, right, of not rejecting. So we've got a 56% chance that even though the actual number of sightings is 5, we've got a 56% chance of concluding that it is actually 3.2. That seems fine. So the idea is that this is not a very sensitive test. It doesn't pick up on small errors, right? It doesn't pick up on small variations of what I should get particularly well. So it's got a low power. So 20 bulbs, I'm going to very much paraphrase this one because we're running over. We got 20 bulbs, probability of 0.1. The test rejects H0 if 4 or more defective bulbs are found in the sample. So the size of this test, well, it's just the probability of rejecting. So what's the probability of rejecting? That is the probability that X is bigger than or equal to 4. So let's go here. We want a right-hand tail. We want bigger than or equal to 4. N is 20 even. P is 0.1. So 13.29. All right, so that is my size. And it is the probability of a type 1 error. Okay, i.e. the probability of rejecting H0. Now, what if the actual true proportion of the defective bulbs is actually 0.2? Well, then X would have a binomial. Oof, I think the laptop needs a break. Now, what is the probability of not rejecting H0? Well, we would not reject H0. If we were rejecting with 4 or more, we would not reject if X is 3 or less. But that is if it's P of 0.2. So let's go back here. So when will we accept? 3 or less. That's there. Nope, need to change the P to 0.2. So 0.4114. That is the probability of a type 2 error in this case. But again, that depends massively on that 0.2. So the power of this test is 1 minus that, which is 0.5886. Okay? i.e., this is the probability of correctly, right? This is the probability of correctly deducing that proportion is greater than 1 if the proportion is 0.2. I've paraphrased a little bit there for time. Oh, what's the title on the booklet? That's interesting. So you got title meaning. I'll have to have a word with our TA about that one. Sorry, gang. Do apologize. Have to have a word with our TA on that one. Are you saying that I might have got part A wrong? Let's just go do that again. P is 0.1. We reject if 4 or more. Now I get 0.1329. Oh, apologies, gang. Thanks, Josh. Don't know how that happened. Okay. Cool. If Fifth Kebab got it, then we're all sorted. All right, we've overrun a little bit here, gang. So literally, type 1 really is your significance level. It's the probability of rejecting H naught. Just think of it that way. It's the probability of rejecting H naught when you shouldn't. I.e., so think of it this way. So all our calculations, right, when we do our hypothesis test, we assume that H naught is true, right? When we calculate our probabilities in any of these hypothesis tests, right, any of my probabilities in these hypothesis tests have been done assuming that H naught is true, right? We assume here H naught is true, i.e. this does have the correct distribution. We assumed that P is 0.1. We assumed that lambda is 3.2. So in all of these hypothesis tests, we assumed that H naught was true. A type 1 error is, well, H naught is true and you reject it. Okay, fine. So what's the probability of landing in the critical region? I.e., what is the probability of rejecting H naught? And that is the probability of a type 1 error, and that is the size of a test.